Hello, Internet, and thank you very much for tuning into this episode on this live stream or live webinar or the live workshop or mastering EKS upgrades with Kubernetes Operation Platform. So we speak of what we're actually covering today. Let me give you a walkthrough of us. So upgrading your EKS, Amazon EKS is necessary to maintain a secure and high performing and rich environment. But there are typical challenges you face very often. Number one, if you do manual upgrades, there is a risk of downtime risks, configuration complexities, resource intensive processes, and potential human errors. So that way, you need to learn the strategies for automating upgrades. For that, I will invite my guest today on this webinar is Praveen. Thank you very much, Praveen, for joining us live on this webinar. It's incredible to see you live now. So now, can you give you a quick intro where your role and your stuff you're actually doing currently and your interaction with Amazon EKS upgrades?
Sure. Thanks, Saim. Thank you so much for the opportunity. And I'm super excited to talk to everyone today. So I'm Praveen Kashim Sari. I'm Director of Product with Rafay Systems. Before Rafay, I've spent majority of my time at Microsoft launching products for the Azure Cloud. And then I spent some time with Facebook, or Meta as they call it, handling the privacy and compliance for the Facebook Messenger. And for past 1.5 years, I'm with Rafay Systems, and couldn't be more excited to be working on helping our customers, take care of you know uh, clusters across various Kubernetes distributions. And today I'm going to talk about some of my experiences, some of our customers' experiences across EKS primarily, but also various clouds. In terms of their upgrades, in terms of managing the lifecycle itself, and what are some of the best practices that we have learned and we are helping our customers with to ensure a very smooth, not only lifecycle management, but also upgrades in general for EKS clusters.
Absolutely. So excited to have you here and wanted to know your perspectives or how you're actually doing these with day on hand-to-hand job, because this is one of the topic where people get their hand around, because Kubernetes has 7 components in total, 4 in the control plane and 3 in the worker node. And all the Kubernetes is actually work in a microservices based architecture. So there is a asynchronous call being happening in different places. So having a solid understanding of the strategies are not vital is in, I think, is a survival in this market where we are right now. So we speak about and we go you deeper dive into it. So let's give some people a perspective here. So if I think hope people are aware of this, that Kubernetes project releases new software version on regular 4-month cadence. So new
Yeah.
releases can include additional features, bug fixes, security improvements, all of which are critical for infrastructure running in production environment. While this frequent release cycle constantly provides useful functionality updates, user will often need help to keep up with tasks, including in planning and executing regular cluster upgrades. But upstream changes to Kubernetes project will usually require steps such as reading release notes, upgrading other Kubernetes components for compatibility, resolving breaking API changes, mitigating downtime during cluster upgrades, and recovering from broken upgrades. And due to these operational overhead involved in each cluster upgrades, many users are running older Kubernetes version far behind the upstream recommended version. And running deprecated version will cause its own set of problems, like running buggy software, inability to use the latest Kubernetes feature, and forced cluster upgrade by cloud provider who have minimum version policies. So each release of Kubernetes contain many changes to improve the functionality and stability of Kubernetes cluster. Releases involve changes to core components like kubelet, kube proxy, core DNS, container D, API server, controller manager, and many other core projects required for cluster to operate. So with that, we need to understand the how to remove the cognitive load from developers and to use a tool, some tools that can help us be efficient with the Kubernetes upgrade best practices. With that, I go over to Praveen now so he can share his screen and walk us through the step-by-step journey of a Kubernetes release cycle and how this is happening in cloud providers. Over to you, Praveen.
Absolutely. Thank you, Saim. So let me start by sharing my screen. All right, I hope you're able to see my screen.
Yes, Praveen, I can able to
All
see
right.
it.
All right,
And
I don't know if you will be able to master, EKS upgrades in next 30 minutes or 45 minutes, but we'll try our best to set you up for success or in the right direction, so that you can either work with us or leverage some of the best practices that we're sharing to ensure that you're not worrying about your EKS upgrade cycle anymore. One of the taglines that we generally use on our t-shirts or even at a lot of events that we participate is like, don't hate Kubernetes, right? Why do we do that? Right? Interestingly, Kubernetes is like the cool kid on the block, right? And everybody wants to do containerized applications, run it on Kubernetes. And of course, like, Kubernetes is the best option out there to manage your containerized infrastructure, right? But then, as it starts like a cool thing to do, and as you keep adding more and more to your Kubernetes infrastructure, at some point in time, you realize that it's just too complex to handle, and you're ending up choosing like tens of different tools to manage the lifecycle, to automate certain things, either do in-house automation or leverage third-party tools, and it gets out of hand, right? And that's why people don't really appreciate Kubernetes as much as they should be, because of all the complexities it brings as well. So let's look at what are some of the elements that you need to look at when considering upgrading your EKS specifically to other versions, right? So let's start with what is Amazon EKS, right? So it's basically Amazon or Amazon Cloud, AWS's distribution of Kubernetes, managed Kubernetes, right? And obviously, as compared to a typical raw upstream Kubernetes, EKS is managed service provided by Amazon. It does contain or reduce some of the complexities that you have to bear if you're going with upstream, because like it's running on the cloud, a lot of managed add-ons, a lot of functionality out of box, but again, because it is dependent on the upstream Kubernetes, Amazon EKS has to follow the same release cycle as new version of Kubernetes that gets released. And if you look at what has happened in like last 1 year, you see that there are like 6 versions of Kubernetes that were released, and that's too much, right? Like in 12, it's as much as one version every 2 months, right? And by the time you understand what this new version is bringing, test it out in your environments, and then plan and deploy this new version, you already are dealing with the next version of Kubernetes. So fast paced. So how do you I'd say, like, get yourself on track to meet the pace at which the new versions are getting released, right? A lot of our customers that we're working with, Verizon as one of the examples, has like massive Kubernetes, number of clusters, and then they have a central IT team which is managing the life cycle of all these clusters, and they have to work with their application teams to ensure whatever dependencies that the new version is bringing is also taken care of before you just go and upgrade the cluster, because you don't know what kind of breaking changes each version of Kubernetes is bringing. For example, we'll talk about some examples like 1.24 was one of the major releases, 1.25 was one of the major releases, 1.27 again recently was a major release, right? And they had significant breaking changes that were brought in, and then how we worked with our customers to ensure we were hand holding them and identifying these breaking changes as part of the upgrade process itself, so that they're not stepping in the wrong direction before taking care of certain prerequisites, right? So, anything that you want to add before we move forward into our Kubernetes or EKS journey, and how we what's a traditional process looking like, right?
Yes, absolutely. I think if I think folks who are actually been into Kubernetes, they're aware of the process is like if you do it manual Kubernetes cluster, I think all of the people are using Kubernetes in the cloud is only for the one reason they don't want to actually mishap or miss like they don't want to see what's happening in the control plane. Control plane should be in charge of the more skilled person who has a full 24 by 7 job is to make sure the control plane is always running smooth and without minimal disruption. So that's why they're choosing in the cloud like EKS, AKS, Azure, or AKS, GKE, EKS. And remember, these clusters like AKS, EKS, GKE has always been lacking some time of month. Like if the Kubernetes 1.29 will be releasing, I think in November, then the 1.29 version in Amazon EKS will be end up landing, I think, 2-3 months later down the road. You can expect in June, February, or March, but that process is actually speeding up. I see the 21.28. It's took, I
Yeah.
think, only a month for these cloud provider to bake into it. But if you do it manually, number one, the EKS and cluster upgrade, what do you have to do? I think folks have to understand this. They need to understand the a node where the worker you need to understand the worker node where the applications are running on currently. When the application are running in the worker node, you need to understand the node architecture, like what is the operating system installed on that node, what are the binaries installed on that node, what are the application, uh, what sort of application are actually deployed on that node. And then what you end up happening, you need to deal with chains, toleration, node affinity, anti-affinity, schedulers, and so much more process that you need to understand. And then when you end up having, you need to deal with chains, toleration,
I think we lost you, Saim, but since it might be a network issue, and while you rejoin, let me talk about what does typical EKS upgrade entail, right? So there are two types of versions that gets released with any newer version of Kubernetes, right? There are major upgrades and there are minor upgrades. Major upgrades are something like 1.28, but then minor versions with minimal changes would be like 1.28.1 to 8.2, and so on and so forth. So generally, like if you want to upgrade minor versions, it's not a problem, right? Like it comes with like very minimal changes. There might be one off major change, but generally the major versions are the problem, and we'll focus our conversation today with major version upgrades today. Then we need to understand schedule. If you look at a typical new version release cycle from upstream Kubernetes, it's pre-published, right? So you can go to kubernetes.io and see like what's gonna be the next, when is 1.29 coming, when is 1.30 coming, so on and so forth. However, EKS, unlike some of the other cloud providers, is a little secretive about when these new versions of EKS are coming. So, you need to be on your toes all the time to see when is EKS going to announce support for new versions, right? And then as soon as they announce, like now there's a mad scramble to figure out what these changes are, and how does it impact your applications or your infrastructure, and then what do you what do you do? Like, how do you plan and schedule these upgrades? And obviously, going through the documentation and understanding is a complexity in its own, right? So, one of the things that we do is like, our engineering team, they actually, pretty well versed with all these, complexities that each, version brings, and they basically tone it down for our customers, dumb it down, I would say, make it easier to understand. And a lot of these prerequisites are built in as pre-flight checks as part of the upgrade process itself. So if you are trying to upgrade a cluster which has a breaking change or a dependency, like it has PSP, for example, and 1.25 PSP was removed. What do we do? Like, so we block the customer at that point. We tell the customer, PSP is removed, but your application or your infrastructure has PSP now. You remove that before you can move forward with the upgrade, so that you don't end up, hitting yourself on the foot, right? So now let's look at how does a traditional process, or best practice, I would say, involves in in EKS cluster upgrade process, right? So where do we start, right? We start by an announcement of a new version availability. So we go through the documentation and understand what kind of changes this version is bringing, and how does it impact my infrastructure or my applications, right? And then based on that, you plan for this upgrade and schedule it. Imagine you are a large enterprise and you have multiple application teams, on whom you are dependent on making those changes at the application layer, but you are like a central platform team or central IT team who is in charge of managing the infrastructure and upgrading, scaling, things like that for the cluster. Now, you need to work with these teams to ensure that the prerequisites or any changes are taken care of, and are signed off by the application teams before you can go forward. And once that is done, you typically test it in non-production environments, or I'd say like low impact environments, to ensure that an upgrade is not causing any business impact or not breaking anything for your production environments. It typically do that. Most of them do it in like Dev QA environments, but also there are customers who do it in like Canary based environments, where there is still live traffic, but these are like beta users who know like what they have signed up for, and they might have breaking changes once in a while. And so and this methodology would help customers run the test in production scenarios, and mitigate or catch the issues that are gonna pop up post production, even before it happens, and mitigate it and fix forward, rather than have a mad scramble at the end when something breaks. And then once you're signed, you see that the testing is successful, everything works fine. Now it is about ensuring a plan B or a backup strategy, right? So you back up your data and configuration. So in case of a disaster, you can easily restore your clusters to the state in which they are in currently, right? And because one of the things that we don't recommend our customers is to roll back an upgrade, right? And I don't think there is a easy way of doing it. In fact, I don't think any of the providers recommend rolling back as well, and most of the cloud providers don't even support rolling back an upgrade, right? So it's always if upgrade goes wrong, then get rid of the cluster and rebuild the cluster using your backup. So it's important to have your data and your cluster configurations backed up, so that you can restore them as fast as possible in case of a disaster. Once all these are prerequisites, typically, right now, as part of the upgrade process itself, you start by looking at the documentation, or looking at what are the changes, the big changes that have been introduced as part of Kubernetes version, the newer version that you're trying to upgrade to. And most of the times, with every version, there are some APIs that are getting deprecated by the upstream Kubernetes itself, right? So So it's essential to understand what these deprecated APIs are, and are you using any of them as part of your application or infrastructure layer, right? And then once you make sure all the prerequisites are taken care of, like for example, if you're talking about 1.26 version of Kubernetes, then some of the AWS add-ons need to be at certain version before you can upgrade your cluster. Otherwise, they become as a blocker, right? So ensure whatever prerequisites have been listed as part of the documentation are taken care of. There are no deprecated APIs that are impacting your applications or your infrastructure. And then start by upgrading control plane. So with Rafay Managed Kubernetes, we give an option to the user where you can select both control plane and worker nodes to be upgraded together. But behind the scenes, we are upgrading the control plane first and then the worker nodes. But even before you move forward with that, you need to ensure that your worker nodes are on par with your control plane version before your control plane can be taken to the next version. So it cannot have like two version difference between control plane and worker node. Most of the cloud providers block it, right? If your worker node is below the intended or expected version, then you cannot upgrade your control plane. So it's a good thing, right? And then once you have met all the prerequisites, it's about upgrading the control plane and then upgrade your worker nodes. And as part of the worker node upgrade, there are some changes that are deployed as well. And finally, once your upgrade process is initiated, you monitor and validate the upgrade, right? You can monitor using tools like CloudWatch, or there are multiple third-party tools that you can use. But with Rafay, like it's again, we have an integrated monitoring and observability platform, which lets you look at what's happening in live environment, right? And we'll actually showcase that as part of the demo as well. This is a traditional process. Right now, let's dive a little deeper into what is this planning and scheduling phase, right? Typically, you are figuring out, let's say you are in Kubernetes version 1.24, you cannot do like two version upgrade directly if you want to go to 1.26. So you have to go to 1.25 and then to 1.26, right? So now you understand what are those changes that have been brought between 1.24 and 2.5, right? And make sure you are taking care of that prerequisites or API changes, right? So for example, in 1.24, Docker shim was replaced with containerd, right? If your infrastructure or applications were using Docker containers, then and you upgrade the cluster because Docker shim is no more supported by EKS, your applications might start failing, right? So and what we do is, as part of our prerequisite check, we've automated checking for these complex breaking changes. And if we find them, we actually stop the upgrade process, or we block the upgrade process, so that you're not running into trouble, right? And 1.25, obviously everybody is aware of this complex change where PSP was removed. So what are your options if you don't have pod security policy? Like obviously you want to go to options like OPA Gatekeeper for your policy monitoring and policy enforcement. Then some of the critical components might need to be updated, like core DNS or VPC-CNI or your storage drivers, and they need to be at certain version level before an upgrade is allowed by AWS in this case. And then you have to define what strategy are you going to use for your cluster upgrades. Are you going to do like an in-place upgrade or like a rolling upgrade? Or you want to have like a blue-green infrastructure where you want to have minimal disruption to your production traffic and still get going with your upgrade process. We'll talk about upgrade strategies in a little bit, and then what's the impact this upgrade is going to cost to your infrastructure or your applications. So you need to assess that before you can trigger an upgrade process itself. And then coming to the upgrade itself, right? So some of this we have already talked about. How when you want to upgrade your control planes, the most critical component of your cluster, you want to ensure the prerequisites are met. Like for 1.26 upgrade of EKS, the VPC CNI plugin had to be on or higher than 1.12 version, or the container D runtime had to be greater than or equal to 1.6.0, right? Similarly, what are some of the deprecated APIs, right? We can use some open source tools like KubeNode Trouble or Pluto. It gives you a very detailed report when you run them against your cluster on what are the deprecated APIs a particular version is bringing, and if there any of these APIs are present on your cluster. It would generate a detailed report, and then based on that, you ensure that you're not using any of these deprecated APIs before you upgrade your cluster to the following version. Like we said earlier, bring your worker nodes to the same version as your control plane before you can upgrade your control plane, because a 2 version difference between your worker node and control plane is not allowed, right? So you need to ensure, and with EKS, you won't be able to even upgrade if there is a 2 version difference, right? And unlike upstream, where you might be able to have a forceful upgrade of your control plane, but you're going to break everything in the process. And with respect to worker nodes, what we generally do is we let users pick all this in a sequenced flow, where behind the scenes we sequence them. The control plane is upgraded, and then worker nodes gets upgraded. And worker node upgrade generally involves some of the Kubernetes component upgrade as well, like Docker engine or the termination handler of AWS. I know I'm still waiting on Saeem. Might have some network issues. If there are any questions on the live stream, we're gonna answer that at the end of the show or as soon as Saeem is back, because I'm unfortunately not able to see them through my screen. But rest assured, we're gonna get back to you and answer your questions if you have any as part of the live stream. All right, so this was the traditional upgrade process, right? And with some best practices included as well. But what are some of the challenges, right? Why do we need automation? Why do we need like a streamlined workflow? Number one, because they're like already, we kind of compress them into 5 steps. Like if you really break them down, you're like 7 or 8 steps. They're not very intuitive, and everything is like so separate. They're not like integrated, so they're not intuitive, and it's always possible for human errors, right, with so many steps involved in upgrade process. And as you have more and more clusters getting coming in, you have more different types of applications running on them, but all of these are managed by central platform teams in most of the large enterprise organizations, which means there's an increased complexity, right? So what do people do? They will fall back to either using a bunch of third-party tools or do their own homegrown automation. The problem with that is now you have to manage the life cycle of your automation as well, right? So it turns out to be more complex and expensive than how it starts off. And with all these complexities and opportunity for error, it might lead to mistakes that would eventually lead to downtimes or dollar impact for your business, right? But more than anything, this involves significant cost, both in terms of time and effort, right? If you look at a typical industry average of upgrading a production cluster, it takes about 7 days, about 45 hours of somebody's time to be put into upgrade a cluster, right? So that's why you tend to automate. But then again, problem with homegrown automation, like I said, is expensive, right? You need to maintain the life cycle of this automation as well. Hey, welcome back,
Yes.
Saeem.
Oh, sorry, I was disconnected for a minute. Sorry for that. But one question on that time, like while you actually in Kubernetes, you do have HPA and VPA, horizontal
Mm-hmm.
pod autoscaler and vertical pod autoscaler. Those
Mm-hmm.
scaler actually scale up your application based on demand and the request.
Yeah.
When they actually scale your application, they scale the node and increase the node sizes. Sometime you might be there are some node having prior version as compared to the other that's at the
Yeah.
newest version. So number
Right.
one, how to tap this challenge, number one. And then I think we can also, you can take a question number two as well. Like, is it a
Mm-hmm.
possibility, like when you're actually upgrading the cluster, is there any
Mm-hmm.
tool, is there any service that can tell you upfront how much the cost associated uh, with these upgrades, like if you do upgrades on a sequential fashion or the job fashion,
Mm-hmm.
and
Mm-hmm.
sometimes you actually need a more finer grained node because sometimes there's a very huge in future actually roll out and that node
Mm-hmm.
capacity doesn't manage those as well. So cost
Yeah.
optimization and plus PPA and HPA.
Yeah. So I think we just talked about it, before. So one of the things that you have to ensure is that your worker nodes are at the same version as the control plane before you can upgrade your control plane, right? And all this node scaling up and down, and that that might be one of the things which would um, make your cluster in inconsistent state in terms of some of the nodes in a different version versus the other node. So it is important for you to make sure all your worker nodes are at the same version. So what generally you do is, like, at least in Rafay's terminology, what we do is, if there is a node, even if it is like one single worker node out of the entire cluster, which is um, in a version lower, we actually show it in a banner saying that upgrade is available, right? And at that point, you can actually go into the cluster and see, like, what are the different nodes, what are the versions. Can even use our CLI and then do a kubectl command to see what are the versions each node is working on, running, and then you can target a specific worker node and then upgrade it, so that you are consistently bringing all your worker nodes to one version before you can work on upgrading your cluster to the next version, right? With respect to your cost question, right? So I mean, people use different third party tools to analyze cost, but it is generally the cost of running your infrastructure. It is not like a prediction of cost when you upgrade the cluster, right? So because, let's say, the new version of Kubernetes requires more powerful nodes behind the scenes, right? Which means you're adding the infrastructure cost. It's not available out of the box, but you can do like back of the napkin calculation by looking at, okay, so today I'm going to use like an instance size T3 for my current 1.25 cluster, right? But then when I go to 1.26, I would not be able to use it anymore because I would need T2, right? At that point, like you need like X number of nodes by the difference in the cost. So that's going to be your new cost. But if you use, if you are a Rafay customer, so we have a inbuilt cost management option, which actually tells you historical trend of your cluster cost, right? What's the spending on the cluster, how much of it is really leveraged or used, and how much is like running waste. Like, for example, you use a cluster and only 30% of its resources or infra resources are being consumed and 70% is sitting idle. We show the differentiation between the usable cost and the idle cost, right? So you can use things like Cost Explorer, but you need to pay for license, right?
Absolutely, 100%. I think that's the most obvious question we people feel like having a
Yeah.
new version. Like I think some of the companies, some of the teams are like very older in Kubernetes. To be honest,
Yeah.
I can't imagine, but there is such true. Like I believe
Yeah.
some of the companies, some of the still enterprises are using 1.18, 1.19
Yeah.
version.
Oh yeah,
And that's
absolutely. Like I've been dealing the early part of this year with a couple of customers. I don't want to name them on, on this recording, but they were on like 1.19, and we had to like literally drag them out. So even though the cloud providers stopped supporting, like we had to support the customers, and we had to literally drag them out because there were some really breaking issues that they were dealing with. And finally we were able to upgrade them to the latest version. And I'm actually dealing with a couple of customers right now who are moving away from 1.23, which is end of support this month. Obviously EKS announced extension of support just last week, that you can extend support for one more year, but that comes with a cost, right? So I'm working with a couple of customers who are trying to move away from 1.23, whose support will end this month. I think it's ended like October 11th, I believe, was the end of support for 1.23. So but then thankfully, like we were able to give them a streamlined recipe through our fleet operations, and then move them to latest version of Kubernetes in no time. And we're gonna do like a quick show you a recorded demo on how you can use our Rafay's platform to automate your upgrade process. I'm gonna show you like intermediary upgrade versus like a fully automated upgrade as well.
Yes, absolutely, absolutely. Go ahead. I think like I'm like the point I mentioned, like I spoke to some of the teams, like they are 1.18, 1.19 version, and then they actually start upgrading it to 1.26, 1.26, 27, and they see
Yeah.
the node capacity is actually filling up very
Oh
immediately.
yeah.
And
Oh
they
yeah.
see, oh,
Absolutely.
why this is happening, and is there a tool, is there something to tell us like why this is happening and why our
Yeah.
costs are exceeding? So that is one of the point actually brought up the question around cost is management
Yeah.
as well.
No, absolutely, Simon. And you are right on point when you say like when customers are going through that multi-fold upgrade, right? Like from 1.x to 1.x plus 6, right? There's a lot of like a typical operating system, right? The newer versions will have a lot more complexity and a lot more need for underlying hardware to be available to run the control plane itself, right? So or even the worker nodes, like the Kubernetes version is going to take up some of the resources from the infrastructure, right? And as you go into newer and newer versions, it's going to increase, right? And when you have like a huge difference, like 5 versions, 6 versions, I'm 100% sure like 90% of the customers out there are going to run into capacity issues, where your nodes will not have enough capacity to serve the application there, right?
Yes,
All
absolutely,
right.
absolutely, 100%. Go ahead, Praveen. Absolutely.
Yeah. Now I'm actually jumping a little bit into like how Rafay's automation platform is making it easier to an extent to manage the life cycle of your EKS cluster, but also helping you upgrade seamlessly. Right. Some of the core features that I want to talk about today, which helps you in that upgrade processes, we kind of offer a managed EKS lifecycle approach, which means with through our CLI or our APIs or our UI or even our GitOps or Terraform, you can provision, scale, perform upgrades with built-in automation, right? So you don't need to worry about, do I need to do all the pre-checks myself? Do I need to do look at the deprecated APIs myself, right? No, you don't need to, because we are doing the heavy lifting for you, and we are including that as part of our automation process. But then other standard situation or use case that we run into is large enterprises, right? They obviously they have clusters running in different AWS regions, running across different accounts, right? Because let's say there is a sales, marketing, and HR teams in an organization. Obviously they'll have like 3 different accounts, right? Cloud accounts. But then there might be a central platform team that is managing the infrastructure. Now if they want to perform an operation, they have to go into 3 different accounts and perform this. So and then imagine there are like 100 teams, right? The complexity increases hundredfold, right? At some point, it becomes unmanageable. So what we have done is with Rafay's platform, you get like a single pane of glass experience. It doesn't matter which region of AWS your cluster is running, which account it is part of. You're gonna get the same seamless experience, like showing all your clusters in a single dashboard, right? And you can perform operation right then and there. And you can do the same with our API or CLI as well, right? One of the prerequisites that we talked about in the process upgrade process is build, backup configuration and data, right? With Rafay, you can use our built-in backup capability to back your data and configurations that can be used in a disaster situation, right? Then we also support strategies like Canary and Blue Green that we'll talk about in the next slide. But we also have integrated monitoring and observability platform, so you don't need to get like a third party tool or go to CloudWatch and keep a running log to see like what's happening during your upgrade process, right? If something goes wrong, it immediately is showed in our log on either on the CLI or on the UI, right? And finally, the latest announcement that we have is the automated fleet operation capability, with which it doesn't matter you have one cluster or you have 100 clusters. If you want to perform an operation like an upgrade to the same version, you can do it with a single click approach. And this would have all your prerequisite, all your post verification step bundled into a seamless workflow that makes it upgrade like a piece of cake. We have seen customers taking like 7 to 10 days to upgrade a cluster. With our automated capability, reducing it to like hour and a half or two, right? That's like some of our customers have been super thankful, and we've been blessed to be able to provide a service like this, right? Imagine the productivity gain that your IT teams are going to get by leveraging this level of automation. So anything you want to add, Saim, to that?
Yes, absolutely. I think that, as you mentioned, I think the whole area of the platform engineering right now and the DevOps movement is having these, removing the cognitive load from the developers. And I think if you look at the Kubernetes, the way it's actually manufactured from day one, if you start doing these stuff, then the more important stuff is actually have a very less time for it,
Mm-hmm.
because Kubernetes upgrade required a full skilled individuals that
Yeah,
not only understand how the Kubernetes work, but also the Linux features, also the networking features, also the
yeah,
backup and recovery features, and
right,
these build together to form and I think having a platform can actually lift the job, and then the people work on upgrading their
yeah,
application, making the innovation actually grow for their organization. I think that's where
right,
the 10 has to be, not
yeah,
actually spending hours and hours dealing and troubleshooting the upgrades parts of the Kubernetes. It's look good for learning purposes, but when you're in the enterprises that want to go fast, I think it's
yeah.
very difficult to go
Yeah,
that journey.
yeah,
Our
especially in a production scenario, right? Same. I mean, you don't want your applications to be down just because you want to learn something from doing things manually, right? So with this, right, I want to jump into a demo to talk about one of like the most common scenario that we are running into, right? People are trying to move away from 1.23 because it's end of life right now, right? So we have a recorded demo of upgrading, doing an in-place upgrade from 1.23 to 1.24, and also showing like how the prerequisites actually show what are the checks that we are doing. Some of these things like Docker shim to container D, right? Important, right? So let me jump to that. I know I can talk about it all day long, but in the interest of time, like we need to fast track this a little bit. So let me jump into the demo, and let me get this here.
So I see a bunch of the folks online. Great, thank you very much joining and actually watching us live right now. So it's your turn as well. So feel free to comment, add your comments or question in the comment section, or even in the even in the YouTube chat. So whole purpose we want to know how you are actually leveraging. So now I'm actually sharing the screen of the Praveen's screen. Hope you can able to see it, and also you can share the link with you for that video also uploaded on this channel as well, where you're watching right now. So over to you now, Praveen.
Sure, thank you. In this demo, right? So what we are doing is we are upgrading in 1.23 EKS cluster to 1.24, and we're doing an in-place upgrade, right? So we are gonna start with we're gonna say like we're gonna upgrade both control plane and worker node together, so that customer doesn't need to, or user doesn't need to do like one after the other. But behind the scenes, what we are doing is we are upgrading the control plane first, and then we are seamlessly transitioning to upgrading the nodes as well. And it's like a one-click experience, right? All right, so and then like I said, you can use, if you're familiar with Terraform and your automations are built around Terraform, you can actually use the same and still leverage a platform to perform your upgrade. You can use our CLI, you can use a GitOps pipeline if that is what your organization is using for all your infra operations, or you can use our UI. It's like super easy to do it. And in the interest of easily explaining, right, we're going to use UI in this demo. Right, so what was the biggest change from 1.23 to 1.24? Like I said, Docker shim is no longer supported, and you have to move to containerd going forward, right? And this is something that the customer had to do out of box before even coming to the upgrade. Now we do it as part of the prerequisite ourselves, bundled into the upgrade workflow. So this is one of the cluster. This is our console, by the way, and this is one of the cluster which is on 1.23. As you can see, that 1.24 version was available at the point, and we said like upgrade is available. So it's super easy for the customer to know that, am I running on the latest, or is there a newer version, supported version is available, right? All you need to do is click on that upgrade available, and then you can use our CLI, and it is integrated into the UI itself, right? So you can run our kubectl commands and do the upgrade yourself. But let's say you want to click on the UI, and now here you can see we give you an option to upgrade control plane and node groups together, right? And that's what we are going to do. But behind the scene, like I said, we're going to upgrade control plane first and the worker nodes in a seamless fashion. Now, started with pre-flight checks, which is integrated into the workflow. So you don't need to do any of those like 5 different steps we talked about separately, right? So we did the pre-flight check, and one of the checks that we did was Docker mount. So this cluster did not have the Docker mount, so they would be able to move forward. But imagine if this cluster had a Docker mount. What we would do, we will fail this pre-flight check and ask the customer to fix it. In our next version of the platform, we're gonna separate these two out. Like you can run your pre-flight checks independently, so that you can do like a dry run and collect all the issues that your cluster have before you can do the actual upgrade. And sometimes, let's say you are running a test cluster and you want to override a failed pre-flight check, you can do that as well in our coming version. But right now, we want to ensure the cluster is safe and secure, so we don't allow a failed pre-flight check to pass and move forward with the upgrade. So here we did the pre-flight checks, and we start with control plane upgrade. And once the control plane is upgraded, we upgrade the add-ons for the control plane, right? Like if there is a managed add-on like VPC CNI, we do upgrade that, right? And you don't need to worry about doing all these add-ons yourself out of the box, right? And then we move to upgrading the node groups. So here you can see the status on the UI itself, or you can run a live query using CLI, and you can see the version changes of your different nodes, right? You can see control plane is upgraded, and the worker nodes are still on previous version because the worker node upgrade is in process, right? As we move forward with this demo, We upgraded the node successfully, and we also do a bunch of post validations to ensure all these upgraded nodes or control plane and worker nodes have come back online and are healthy, and there's no other problem that we are sensing. So this is also integrated into the upgrade process itself through our platform, right? And then once all this is done, you're ready to use your latest version of the cluster. It was that easy, right? But then when we talked about a bunch of steps or processes that are required to upgrade, it sounded so complex, right? So we are absorbing all that complexity and dumbing it down for the user to easily upgrade their clusters from one version to the other version for EKS.
Yes, absolutely. That's the same strategies we already spoke about.
Mm-hmm.
Having that you have, that's the same strategies that we already spoke about. Understanding the EKS upgrade process, and then you have a planning and scheduling the upgrades, and then the third part is you can test the upgrades in non-prod environments. So, is there an opportunity in a platform we can leverage that part, like in test the uh, newer version in a non-prod setup?
Yeah, yeah, absolutely. And the next thing that I wanted to talk about is, one of the things that we talked about was the multi-cluster management and automation bundled together, right? Now with Rafay, it doesn't matter what kind of interface you are familiar with. Let's say your organization is fully Terraform based. Doesn't matter. We have our own Terraform provider. You continue using your Terraform modules and use leverage Rafay's platform to upgrade or do any of the lifecycle management capabilities. Let's say you are familiar with CI/CD tools like Argo or GitOps. Doesn't matter, or just CLI. You can still leverage Rafay. We have a beautiful self-service wizard or a UI, and if you are familiar with GitOps and want to manage infrastructure through our GitOps as well, we have infra GitOps where your infrastructure is defined as a configuration element, and any changes to the configuration can be reflected on the infrastructure and vice versa. That way, you have a single source of truth, which is your configuration, that tells you what's the state of your cluster is and what changes is it going through in a periodic fashion, right? So that's what we call two-way system sync, but that's a topic for another day. Now moving on with it, a couple of upgrade strategies that we talked about: Canary and blue green. Very common, right? So Canary, like I said earlier in our conversation, where you have like a production like environment, which is kind of running like a low impact customers, where you generally deploy your upgrade first and then let it bake, and then once everything looks good, then move your upgrade bits to your production environment where there are more higher impact customers or higher impact users consuming your applications. This requires additional set of infrastructure, which is obviously cost dependent, but it gives you a safety layer before you can move forward with your upgrades. And the other one is blue green strategy, where you have two parallel environments running with one of them active, one of them in passive, or you can have active as well, where you generally use your DNS to route traffic to one environment, and you upgrade your passive environment and do a testing there. And if everything looks good, redirect your traffic to the upgraded environment, and now take the passive environment and upgrade it. This is also cost intensive, but then gives you high availability, and also ensures that your production environment is not going to get impacted through a deployment. It can be an upgrade, it can be an app deployment as well. So these are two common upgrade strategies that most organizations out there use, apart from like typical rolling upgrades.
Yes, and just a quick question on that. And let's say
Mm-hmm.
uh, if in a blue in a let's say Canary deployment, people
Mm-hmm.
tested out to eventually roll out a more and more user. Let's say in a 70-30 ratio, and then
Mm.
eventually in
Yeah.
70-30 ratio, something very bad happening because of the heavy traffic to the new
Yeah.
version. So once that happens, is there a strategy to roll back into it?
Yeah. So, like I said, upgrades, we don't recommend rolling back. And rolling back is not possible in majority of the cases. So generally, that's why you have like this blue-green environments, which typically give you that safety net, right? So um, let's say you have your blue environment, which was upgraded, and then from 30, slowly you have increased the traffic to 70%. And then that's when you hit the problem. What do? You route the traffic back to your unupgraded environment or previous version environment, and then fix the problem with the upgraded environment before routing the traffic back, right? That way, it's just, maybe it will impact the users for a split second or few seconds while the traffic is getting rerouted, but the impact is very, very minimal with this approach.
And also, like one final quick question on that front, like, is it a possibility to use both approaches simultaneously side by
Yeah.
side, having
Oh
a
yeah,
Canary?
absolutely. Absolutely, Simon, and you actually touched upon it, right? Like, for example, let's say I have blue-green environments and I upgraded the green environment, which was passive. Now I'm going to pick that 10% of the low impact traffic, let's say my own organizational traffic, to green, right? And let it bake. That becomes Canary in itself, right? Because I'm only allowing the low impact traffic there, right? And then as I see that it's stable environment on the newer version, then I start migrating the newer traffic, right? If you have a good routing mechanism for your different types of customers, then the blue green can also include Canary, the way you route the traffic to.
Absolutely. Thank you very much, Praveen. Go ahead.
Sure. All right. I know we have only 3 minutes left. I quickly want to touch upon our latest feature, which is automated fleet operations. And, how does a typical automated workflow look, right? So it has a bunch of prerequisite checks. In case of 23 to 24, we wanted to check deprecated APIs, if any, Docker shim being used or not, and then PCB configured or not. And then if any of this was true, then fix it, and then move forward with upgrade. And then you start with control plane, and then eventually roll the upgrade to all the worker nodes. And then finally, after the upgrade was successful, post upgrade checks to make sure application health is intact, right? So this is a typical upgrade flow. With fleet operations, we have um, done all this using our fleet ops methodology, where a fleet plan consists of a target that you can define. What are the set of clusters that I want to target? Is it going to be one? Is it going to be 100? Is it going to be the entire organization, right? You can define that. Then what is the desired operation? In this case, the desired operation is upgrading the clusters from version n to n+1. And then what are the prerequisites, like pre-hooks, as we call it, right? Like what were the deprecated API, right? What are the prerequisites that were required? Do I need to get approvals for each of this from the application teams or any of the central approver, right? All this can be bundled into pre-hooks. And then finally, after the upgrade is complete, post-hook or post-validation, which includes health of my cluster and a few other things, right? To ensure the cluster is up and running. To quickly switch, let me quickly switch to a demo and talk through about how this looks like in real life.
Yes, and I think while you are sharing your screen right now, can you touch upon a few, like one use case? Like, is it for, let's say you have 1,200 of cluster residing
Mm-hmm.
in geographical locations, and you wanted to upgrade all of those cluster
Yeah.
with new version of Kubernetes at once?
Yes, absolutely, Simon. And great point, right? Like I said, because we already support multi-cluster management, it doesn't matter where your cluster is running, what geography, what account it is based out of. We treat it as the same. Right now, if you want to target like 1,000 clusters which are spanned across 10 different AWS regions and are part of like 100 different accounts, they still are treated as peer clusters, right? Which means like you can pick or target all these 1,000 clusters at once, and then with one click you are pushing the upgrade to all of them. But do you really do that in a production scenario? maybe, right? Because let's say if there is a security vulnerability and you want to update an application, you can do that as well. So it's not limited to upgrades. It is something that you can use for other operations as well. In this demo, what we are going to do is we're going to check for deprecated Kubernetes APIs, and we're going to upgrade the cluster from 1.23 to 2.4, and then we're going to validate that the cluster upgrade completed successfully and health is good for these clusters. Right. So here I have a couple of clusters, demo cluster AP1 and AP2, which are in Kubernetes version 1.23. And I have a fleet plan, which would basically include 2 clusters. And those 2 clusters are listed here. And I have basically, like I said, pre-hook, which is checking for deprecated APIs for 1.23 version. And I'm using a tool called kubebug, which is very similar to kube no trouble that we talked about earlier in the conversation. Then as part of the upgrade, we are upgrading the clusters to 1.24 version, and we are upgrading both control plane and worker nodes together. And then as part of our post hook, we are making sure that the clusters are back healthy, all the nodes are healthy, and the clusters are in ready state. That's how we determine whether everything is going good with the cluster. Right? And my targets here, like I said, here I have selected one project in which there are 2 clusters, but I can select all the projects in my organization as well. And we use something called cluster labels, and these labels are used to determine or filter my target clusters that are going to undergo this operation, right? And what we are providing is, if you are a very dev centric, or you don't like UI, or you are more familiar with configuration or code elements, right? You can use the YAML form and make these configuration changes or create the configuration as well. And this basically means like you can use this as part of your CLI or your Terraform module as well. Now we're gonna trigger this operation. As you can see, the state of the fleet plan starts with a pending, and then once all this data is loaded onto controller, it starts picking the clusters and starts with a pre-hook configuration, right? As part of pre-hook check, we are we have been able to check that this cluster doesn't have Docker shim, and we will move forward with the actual upgrade process. And as part of the upgrade, you can see from the UI that the upgrade jobs are triggered and the pre-flight checks are completed, and the control plane upgrade is in progress. And within few minutes, as I move forward in the video, we were able to complete the cluster upgrade, and then we did the post hook, which is the health validation, and then we were able to complete the health validation for these 2 clusters. And if I go back to the clusters page, I can see that the clusters are now, the version of the cluster is 1.24. You can see it from here that the Kubernetes version, new Kubernetes version, is 1.24 on these 2 clusters. And for this demo, we have taken 2 clusters, but you can pick like 10 clusters or 100 clusters, it doesn't matter, right? And with the live dashboard, you can see what is happening with your upgrade process in real time, right? That way, you don't need to have like 10 different tools to monitor and 10 different tools to do prerequisites and post-validation steps.
That's super impressive and super interesting for, I think, folks as well. And we'd love to see the comments, what people feel like. So just a few questions I think might people have on that point is, let's say you are checking the nodes, which version like Docker shim or the deprecated APIs in Kubernetes, wanted to fleet it out. Let's say you do a rolling upgrade on one of the cluster, like now we're doing in a fleets, mean 100 and 1,000 of the cluster.
Yeah.
Let's say 10 of the cluster haven't got updated the way it the way it's expected to be? Is there
Yeah.
any updates to the developers or the engineers who are actually wanted to be aware of this activity that 10 of the cluster haven't updated
Yeah.
in a new state?
Great point, Saim. Like, so today you can go to the dashboard and download the log, which actually tells you why these 10 clusters, what are these 10 clusters, why they failed, and basically go perform remediation action and then re-trigger the fleet plan. And even though it has 1,000 clusters, it will only target the 10 clusters because we are upgrading from version X to X plus 1, and all the remaining 990 clusters are on X plus 1, so they will not be touched. Only this, it's like a retry mechanism that you can trigger after you fix the issue. Going forward, we actually are introducing a concept of on error, right? Which means, let's say something failed. Do you want to exit or do you want to continue,
Oh,
right?
got it.
We are going to give that flexibility to the users as well. And going forward, we're also enabling notification on this. So let's say 10 of these failed, you're going to get a notification. It can be email, it can be Slack message saying that, okay, your fleet plan completed, but 10 of these clusters failed and this is the reason they failed, right? That notification feature will be available very soon.
Oh, super. That's super impressive because I think currently people are lacking this feature. Like the 10 of the cluster are failed, we know it, but I don't want to re-upgrade the all the 90 version of
Yeah.
it. Right now, there's a very less solutions available in the market. So I think that would be a very catchier for people who are actually listening to us right now. So over to you before we wrapping up. Any final points, any final consideration that we wrap up the discussion?
No, I mean, so this is something that we have done based on our experience with all the customers that we are dealing with, and all these customers that we are dealing with are, the S&P 500 customers. They are like very large organizations with hundreds of clusters, and we run into very complex use cases that they have. So and that's basically acting as our input in terms of how we are adding features or enhancing features to make lifecycle management of EKS clusters and also the upgrade process super seamless for users, because we want them to not spend too much energy on doing things that are not very productive, like sweating around upgrading or failed upgrades.
Yes, absolutely. That's super impressive as well. And remember, like people, folks, we all like what we discussed right now today is upgrades need a plan, strategy, and a wonderful skilled team to do it. And either you find a skilled individuals who have the nitty gritty detail of everything happening under the hood, or you can adopt a solution like Rafay Kubernetes Operation Platform to do it just a click of a button. So that you need to find, you have to take a trade-off, have to train your skilled individual, hire them and educate them all the upgrade process. And remember, these things happening in a sequential manner. Kubernetes 1.20.9 has some very new features in it. 1.28 added new policies in Kubernetes, the PSA, the PSP is deprecated in 1.24, and there are more and more deprecation will be available sooner. Might be the gateway API, if you look at the Kubernetes, is now getting more granular popularity in the ecosystem. So now what's happening to the open service mesh interface that the community actually added? What happened to those features? So remember, it's a very tough job. So having a platform is easier job, and make sure you actually work on the stuff that is important and vital for your organization, businesses, and revenue. So that with that, it's been super happy and super handy debate. So Praveen will be in the KubeCon Chicago, that happening 2 weeks from now. I think quite a trend, might be a 17 to a 15 day, I think max. There's Praveen is will be there in the Rafay booth, and Praveen will be in the Parallels open source project. So you know how well the Praveen actually able to talk us through and educate us through the process. So it's super handy if you go and speak with him, have a coffee chat, and speak about the stuff you actually doing with Amazon EKS upgrade. With that, thank you very much for tuning in. I really appreciate the number of people joined us today. So stay healthy, stay safe, and we will be monitoring your question in the chat in a future to understand what the way you are actually doing the EKS upgrade. Thank you very much once again, Praveen, for your wonderful crafted presentation and demos. And your 70 minutes of time is worth spending on understanding the most crucial topic of the time of mastering Amazon EKS upgrades. Once again, thank you. Stay healthy, stay safe. Bye bye, everyone. We will meet you again with another webinar.
Bye.